Alright, we're going to work on Chapter 3, Problem 55. If we look at this problem, it's a car rolling down a hill at a constant acceleration for a set distance, and then rolling off a cliff. So there are two parts to this problem. There's a single dimension motion problem while it's rolling, and then there's a projectile motion problem while it's launched at an angle. First, we need to find its velocity going off the cliff. So we'll start with the single dimension. And when we solve, what we're going to find is that we know a lot of information, but we don't know the final velocity and time. We don't necessarily need to solve for the time, because we can use v final squared equals v initial squared plus 2a delta x, and we'll solve that the final velocity is 20 meters per second. And the great part about this is now we know with just motion in one dimension what the what the initial velocity is in projectile motion. Now for the initial velocity, that is, it's going to be launched off the cliff at 20 meters per second at 24 degrees below the horizontal. We'll choose our coordinate system. So positive is away from the cliff and downward, and we'll do this. Simplifies the problem as most of our variables will be positive. And then for the x and y coordinates of the velocity, we'll use cosine and sine. And we'll verify at 24 degrees, I would expect the x coordinate to be larger than the y coordinate. It's 24 degrees is less than 45. And I do find the x coordinate is larger than the y coordinate. Going on, we fill in for acceleration that we know, and it turns out we don't know the final position in the x direction, we don't know the final velocity, and we don't know the time. Now I could use the y final equation equals y initial plus vit plus 1/2 at squared to solve for time. One, I don't necessarily need that right now. But two, that ends up in a quadratic, which some of you may not want to use yet. And but if you're comfortable with it, it's a quick way to get to time. We can solve for the final velocity with the same equation before. We'll use the y direction. And solve in the y direction, the final velocity is 25 meters per second. And then we can use an equation to solve for time in the air now that we know the initial and final velocity. And we can find that the time in the air is 1.78 seconds. Knowing how long this is in the air, and knowing my velocity in the x direction, multiplying velocity times time should give me the change in position, because x equals x initial plus vit. So we've got 18.27 meters per second times 1.701 seconds. Remember, always write down the number. Do more sig digs than you'll need to avoid rounding errors. What we find is the final position is 32.5 meters from the base. Hope this worked for you. Try to repeat this problem, but use the quadratic formula for the second part. It's a good practice for going on, and it also shows that we can do the problems in multiple ways if we're familiar with the equations of motion. Thank you.